So let's go through an example that involves a moving object along a level surface. So we have a 1,000-kilogram car with it slowing to the left and is encountering a friction force of mu equals 0.3 as it's approaching a traffic light, and we had to find the horizontal acceleration. To begin with, we would identify the given values in this problem. First, we have the mass of the car, which is 1,000 kilograms. And then we have mu, or the friction coefficient, is 0.3. We also know that AY, or the acceleration in the y direction, is 0 because there's no vertical acceleration in this problem. And it's also stated that it's also given that 9.81 meters per second squared is the gravity on Earth. And the thing that we need to find is the acceleration in the x direction. So what is a sub x? Now moving on to diagram, we would create a free body diagram. We know that gravity would be facing downward, which is mg. Since it's slowing to the left, friction would be to the right, and we would have normal force facing upward, since it's an object that's moving across another surface. Now, since we finished the diagram, moving on to the relevant equations. The relevant equations in this case would be the net forces in the x direction would be mass times acceleration in the x, and same thing for y. And in this case, we would also use friction equals the friction coefficient times normal force. And let's go through the analyze section of this by breaking down all of these equations and working with each of them individually. So now we look at the net force in the x direction, and we notice that the only force that's involved in the x direction is the friction. So that itself is the net force. So the friction is equal to mass times acceleration in the x. If we left this there and then went on to work with the net force of y equals mass times acceleration in the y direction, then we would notice that the two forces that are involved are normal and gravity. So we could say that normal minus gravity is equal to the net force in the y direction, and that's equal to 0 because we know that AY itself equals 0. So if we were to set this equal to each other, then we would have normal equals mg. And then if we were to use the fun equation, as we call it, we would know that normal is equal to gravity, so we could just plug that in to normal and say that friction is equal to mu times gravity. And then you could say that F is also equal to mass times acceleration in the x, so you could say mu times mg equals mass times acceleration in the x, and say that acceleration in the x is equal to, when you divide it by both sides, it would be ax is equal to mu mg over m, and cancel both of them out. Then you would have ax equals mu times gravity. Now you would have it as, that would be the analysis section, and moving on to solutions, you would just plug it in. You just plug in the values that you have in the identify section and say that ax is equal to mu, which is 0.3 times 9.81 meters per second squared. And so the horizontal acceleration for this car is 2.943 meters per second squared. That's your final answer.